Welcome everyone. A little less testing, a little more quality. I am Joao PROENCA, and I am a quality engineer that works at Ada Health. I come from Lisbon, Portugal, and I'm very happy to be here for the first time in Budapest. You're probably looking at the title of my talk and wondering, what the hell does he mean with this? Is this going to be one of those talks about how you shouldn't be doing any testing? No. Testing is a very important part of what I do as a professional. This talk is about how quality is something very complex, and you can influence in many ways. And I've observed throughout my career many ways in which quality was influenced that didn't involve any testing at all. Okay, but I'm in no way devaluing testing as a practice, of course. And so, a quick agenda of what I want to cover. I'm going to tell you a small story about testing. Then we're going to talk a little bit about risk and different ways in which you can manage risk. And finally, we're going to go into how quality has multiple dimensions. To start us off with this small story, once upon a time, a long time ago, I was at the beginning of my career, and of course I grew up in Lisbon, Portugal, as I said earlier. But I had a lot of friends that moved into the Netherlands because they all went to work for the European Space Agency. And this was very exciting for them, and it was very interesting. And one day I went there to visit them, and they invited me to visit the facilities in which they worked. These very large ESA facilities that were really awesome, you know. When I say that they invited me, they totally infiltrated me there. It was completely illegal. This was like 15 years ago or something like that, so I don't really care anymore. I don't think they're gonna arrest me now. But I just joined them in their group, and we just walked in. But as soon as we got into the facilities, I figured that actually what they were doing there was a lot of testing, really a lot of testing. Not of software, but of hardware. Everything that you can think of that you want to send to space. And so they started, showing me all of these different rooms and hangars. And the first one was this big, massive room where they simulate the sun. So they put a piece of hardware there in the middle. You need to leave the room if you don't want to die, and then they turn on something that this giant light bulb turns on, and it will, simulate the conditions in space when the sun is being cast over the equipment. Another room was all about sound. They would turn up the decibels inside the room and see if the hardware was able to sustain the decibels of when things are being flown to space. Another room was very interesting. It had all of these cones in the walls, and these are filled with carbon powder, and they're there to basically absorb all of the radio waves, so that you simulate conditions in space where you're emitting radio waves but not getting any back. So this was a room for that, and this experience got me thinking a lot, because we as Europeans are, sending a lot of money to ESA for all of this testing to happen, because, of course, if you're going to send rocket ships to the moon or something like that, you're not actually, you don't have the chance to fix things in production, right? If they're already midway, if there's a critical bug, well, that's a massive failure. And at that time, I was at the beginning of my career, and I started thinking, well, I don't do this sort of in-depth testing when I'm testing software. Maybe I'm doing something wrong. But then I started thinking how we've also been here in software in the past, at least in my mind. If we go back to the 80s, let me give an example with video games. Back then, if you wanted to release a mainstream video game, you had to, even though these games were much simpler in nature than they are today, they had to have a lot of testing, because a critical bug meant that would go onto the golden master that was sent to the factory to be copied multiple times, and a critical bug would be something that would linger in the game forever. And it could even mean the failure of such a game. This actually happened in the early 80s with a game called E.T. that was rushed into production, let's say, because Atari wanted to coincide the release of the game with the time when the movie came out. And it ended up being a very notorious failure of a video game because it was riddled with bugs and design flaws. And these games actually ended up in a landfill in the US, and they precipitated what they called the video game industry crash of 1983, if I'm not mistaken. However, if we fast forward to nowadays, this isn't the world where we live anymore. Of course that you gotta do a lot of testing over video games because they're much more complex in nature, but the way you deal with problems if they come up later in the game is completely different. This is just a recent example of CD Projekt Red's Cyberpunk 2077 that came out in 2020. And when it came out, it was this like really ambitious project that basically failed upon launch. It was riddled with problems. People said this was a massive disappointment, and most people believed that they wouldn't be able to recover from that. But actually, the company didn't give up, and they started patching and patching and patching and putting in the features that were missing, and the game even got re-reviewed a year ago or something, and all of a sudden it got really good reviews. And there was even like an expansion release that won awards, Phantom Liberty. And this is kind of like the world where we live in today, where a lot of times you see products going into the market, they're kind of like not totally finished. It is a bit controversial, and it's happening a lot this year with these new AI products that come out, even though they're not prepared. But it is the world that we live in, okay? So the key thing I wanted to bring to you with this example is that it's all about the risk, right? Testing is a way of managing or addressing risk, but there are many more. In my mind, I like to use this heuristic. There's 4 main categories of ways to address risk. You can prevent risk, you can accept risk, transfer risk, or observe and react to risk. Preventing risk is essentially where you do a lot of testing, right? You believe something may go wrong, so we're going to test to make sure that that thing won't go wrong before we go to production. Accepting risk is when you believe, well, the risk isn't that high, so we really don't care about it. Sometimes risks in organizations are treated the same, wrongly, because some risks can just be accepted. And so this means having a proper risk, let's say, assessment process within your own organizations. You can transfer risk. That doesn't make a lot of sense from a software engineering perspective, because it's about having insurance when you transfer the risk of something bad happening to a third party. And then there's one which I find very interesting called observing and reacting to risk, which basically is you send something to production. There's certain risks that you can't probably anticipate, but if you're really good in knowing that those problems are happening and are really fast and efficient in reacting to them, maybe that's a better way to address risk. I was once working in a company that was facing this reality because they had a system that was too hard to test, in the sense of it was a development platform, so that meant owning a programming language, owning monitoring tools and things like that. And the thing about being in such a space is that it has a lot of unknown unknowns, things that you can't really predict that may go wrong. And in those cases, when you own a programming language, you won't be able to anticipate the things that users will figure out that they can do with that programming language. And so it was basically impossible for me to test for those things. And I remember that back then, there was a pivotal moment in my career when I joined one of those teams working in that product. It was a massive monolith. So basically, we had this huge development platform that a lot of people throughout the world used to develop mobile and web applications. But it was basically one binary that that people either ran on their own servers or we would run in the cloud. And the thing was, because it was this big monolith that came together in a single binary, a lot of times what would happen over the years is that the release cycles became really bad because there were a lot of teams working on the same code base. Everything needs to come together to build that unique binary, but then at the end, the slowest team or the team that was facing more challenges at the time would set the tone for everyone else. And this became kind of like a giant snowball problem where we need to test a lot of things because it's a complex product and it needs to be released on that date because we only have a 3-month release cadence. If we fail this one, we need to wait another 3 months. When I joined the team, they were basically telling me, you need to do more testing. We feel that we're missing testing. When I believe that was exactly what they didn't need. I had a different idea. The problem was living within this monolith structure and this, let's say, way of doing things. And when I looked at what the team was doing specifically within the larger sense, I thought, well, this team has a big opportunity to stray away from the monolith. They basically owned a number of administration consoles for doing version control, for looking at logs and stuff like that. These were basically web applications, and I was like, why can't we just remove the web applications from the monolith and release them independently, and maybe we are able to release it faster and more frequently, and with that, I think that quality will improve, not with more testing that is just adding up to a space where you're not going to be able to predict everything. So I embarked on a 1-year journey where first I had to convince the team that this was the thing that I should be doing as a quality engineer. Then afterwards I had to have business buy-in so that they would realize that this was a good idea even from a business perspective. Once I was able to do that, I basically got the organization to agree on the value of doing such an initiative. Afterwards, a very interesting part was getting the architectural changes approved by the architects in their ivory tower. And even tougher than that was aligning with more teams because all of a sudden, a lot of teams need to open APIs and whatnot because we're going to live in a separate world that goes by different rules. For me, this was getting everyone to agree on the how we were going to do this. Finally, I also had to do a lot of work in convincing people to allocate effort. I'm talking about managers, even a C-level, to allocate effort from teams to put this in place. And for me, that was on getting everyone to agree that we were actually going to do this thing. Being involved in all of these different phases didn't feel like testing. It felt like a whole bunch of different things. One of the most interesting ones during this 1-year journey was in the architectural changes part, because getting architects into a room pre-pandemic to decide on architectural things, it's very interesting. They were basically fighting it off, even shouting at each other, and I thought, well, my initiative may be jeopardized just by the fact that these people can't agree and can't have a proper conversation between themselves. However, I decided, well, I'm going to try something different. I'm going to change the medium. And instead of having these meetings, I'm going to try putting a document well curated and structured by myself with threads on each of the topics to see if that helps with the whole process. I'm not going to put people inside a room anymore. And that was surprisingly, for that context, the key, because after a week, I had agreements on all of the decisions by just, changing the laws of the game. And it really showed me that sometimes the social aspect and being able to facilitate things for others is a very important skill. After a while, we did come to the goal that we wanted to, because we moved away from the monolith. We started delivering things faster. And I even got this amazing quote from someone from customer support that showed me that we had reached the target that we wanted without actually doing more testing. We were actually even doing less testing because we were focusing on the right problems. It showed me that you can test yourself out of a broken release cycle. Now, I worked on many other things throughout my career and ever since that isn't exactly about testing, but they do greatly influence quality. One of them is controlled rollouts, basically releasing in different stages to different classes of your customers. Obsessing about developer feedback loops because it's proven that if a developer gets feedback from testing faster, bugs will be solved faster as well. And even looking at how teams are working in maintenance. Once again, none of these are testing activities, but they gravely influence quality. Now, I've told you a lot about different ways in which I tried to influence quality with these examples, but we're still not even talking about the whole picture. Up until now, we've been only talking, in my mind, about a specific aspect of quality. And this is a model by my good friend and boss, Dan Ashby, that I'm going to use here. And he says that quality consists of three main areas. There's usefulness, correctness, and goodness. If you think about riding a bicycle or having a bicycle, the bicycle is useful because it allows you to go from A to B. It is correct because when you turn the wheels, it actually moves and the brakes are working. And it's good if it looks good, if you like its color, if you think you look cool when you're riding it, right? This is the way I think about it. But if you notice, up until now, I've been mostly talking about correctness of software. I haven't spoken about usefulness or goodness, and there are many ways in which you can influence that as a quality engineer. One example, about a year ago, I had a very good friend of mine and colleague who was battling with this thing within his own team, where he basically felt that we're building this amazing new feature, but I feel that this is not going to be useful for anyone, and I think I may be stepping over the line by going into product owners or product managers and challenging that. And this is a good example because I ended up convincing him of doing that, and that had a massive impact on the project in the end. So it's kind of like when you realize that testing won't fix a useless product, right? If something is useless, there's no reason to be testing. And then another story that I have more on the goodness side of things was a few years ago in another company I was working at, we had this situation where basically we had a health insurance covering everyone in the company, and we usually back then we had to send all of our health insurance claims by mail. And I remember this story because it tells us a lot about goodness. A colleague of mine was passing by me when I was dropping the mail at the reception for it to be sent to the insurance company, and he told me, "Hey, Joao, you don't need to do that anymore. There's an app now." And I was like, what is the app like? That's amazing. I don't have to send letters anymore. And I never forget his response. "It's awesome." Well, actually, it sucks, but it's awesome. And so what he meant was that the app was terrible. From a user experience perspective, it was actually terrible. But it was a completely different league when you compared it with having to fill out claims in paper and sending them in letters to the company. Of course, that later on, so it was an example of a very useful product. It was correct, it did what it was supposed to, but from a user experience perspective, it was really bad. And so sometimes you lean only on correctness and usefulness while forgetting goodness. Okay, quality consisting of these three different things. I told you and showed you a lot of different ways or different topics in which a quality professional can go into if they want to influence quality without maybe doing testing. But there's another way to look at this, and I will use this as a disclaimer. This is another model from Dan, where basically he advocates that all of the things that I've been telling you up until now, and I believe we've already spoken about this earlier in this conference, maybe it's testing at different moments of the development life cycle. So maybe you can think of, for instance, if we're working on the usefulness of something and questioning that as testers, maybe you're testing in the planning phases or the ideation phases, as an example. Okay, I'm at the end of my talk. Sorry for rushing this a bit.
Wait. Joao, you don't need to rush, because so far there are no questions. So if you want, you can still have 4 minutes to finish the presentation. Then
it's fine.
No questions.
It's
okay.
Fine.
Okay.
So the key things I want you to take with you from this talk is what I've been telling you about up until now is that we see ourselves as testers. Quality can be influenced in many ways, not just testing. And that's the way I look at quality engineering at the term, and that's why I call myself a quality engineer. Not just because I am a testing specialist, but because I try to find the opportunities around to influence quality and not asking permission to get into those areas. And sometimes I see testers come up to me asking me questions about their careers, how they can improve, and the sky's the limit in all of these different fields you can walk into to further develop yourself into a quality professional. Thank you.
No, thank you. All right. We have actually one, and we do have time for that one.
Yeah.
You spoke about usefulness, correctness, and goodness. Can you give an example of only goodness without the other two?
An example of only goodness without the other two. I would say I don't have an example present in my head, but it's something like, so for instance, I remember when we were in the pandemic that you had a product, what was the name? I don't remember. Because we were all within our let's say, our houses and we couldn't leave, there was a product that came out that was really successful for that time being, because it was really well made, but it catered to something that was happening then, which was, it was a how do you say, a casting and room meeting software for people to come together and talk about. That product later kind of tanked because the usefulness wasn't there anymore, but it was still really well built. And what I'm trying to say with this is that if you think of anything that a lot of people don't see a point in using, but it's really well constructed. From a user experience perspective, you know what it's supposed to do. You think that it's really well made. That's kind of like a product that's focusing too much on the goodness rather than the rest. I hope I have answered.
Okay. One more. We have time for one more question. How did your boss or employer react to the fact that they hired you to do more testing, but you worked on other topics?
Well, to be honest, that wasn't exactly the case. Maybe I gave that impression, but at the time, my boss was actually the head of quality, and he also was aligned with this idea that quality engineering was more than just testing. And there's a very key important thing there is that management needs to be on board with this idea, otherwise you'll see problems like this.
Okay, I need to know how you got the ladybug after your name. That's just so awesome. All right, ladies and gentlemen, a huge applause for Joao, please.
Thank you.
Thank you so much for this amazing presentation.